everyone, my name is Grayson Duggar, and this is the Physics 2211 Lab 3, Black Hole. The purpose of this lab is to do two things. First, calculate the mass of a black hole, then figure out what initial velocity it would take to launch off of a planet revolving around that black hole, and fly close to the black hole without getting sucked into it, and escape the black hole's orbit while not crashing into the planet's orbit. The main principles used in this lab are the momentum principle, Newton's law of gravitation, and the parallel and perpendicular components of net force. After performing this lab, I calculated that the black hole has a mass of 6.9 times 10 to the 33rd kilograms, an initial velocity of negative 4.6 times 10 to the 6 x direction, 1.9 times 10 to the 6 y direction, and 0 in z direction meters per second, and that would help escape the black hole's orbit. The main equations used in this are the gravitational force equation, which is F-grav equals negative g times mass 1 times mass 2 over the magnitude of position squared times the position unit vector. Second is the momentum principle, which is the change in momentum over the change in time, and this can be broken down into the change in momentum times the magnitude over change in time times unit vector, plus the change in unit vector over change in time times magnitude. The first of these correlates to the parallel component of the net force, and the second of these correlates to the perpendicular component of net force. In part 1 of my experiment, the system was a star, the surroundings were black hole, space, and everything else in the universe. The initial conditions are shown below. Here is my Python code for part 1 and the result of my experiment. For part 2 of my equation, for part 2 of my experiment, sorry, I'm having trouble today. For part 2 of my experiment, the system was a spaceship, and the surroundings were the black hole, the planet, space, and the rest of the universe, and the initial conditions are shown below. Here's my Python code for part 2 and the results for my experiment. What does this mean? What if? For the what does this mean question, we had to talk about the parallel and perpendicular components of net force and change in momentum. While both the components of net force, parallel and perpendicular, and the derivative of momentum are mathematically equivalent, solving for each of them is unique, and different parts are required for each one. For our experiment, the derivative of momentum uses velocity and mass to find momentum with respect to time. But also in this experiment, the mass of the black hole is needed to properly calculate net force. As for the what-if question, I'm going to be totally honest, I used a bunch of different numbers for about 2 hours for this and didn't get anything, and for my sanity and for the sake of me not punching a hole through my laptop, I gave up. So, have a nice day if you've made it this far. I'm very done with this lab.